Hello, today we are going to go on with our examples on chapter 11, the chapter 11.5 worksheets. So let's review in the chapter 11.5, we talk about multiplication of probability. And then when two events are combined, we want to find the probability of the combination, we can multiply them together. We have not go deep into the symbols like these because they are not very useful for our public exam. But what's most important is that we can multiply the probability when we want to find their combination. Alright, so let's go on with more examples. Last time we finished question 1, and then now we go on to question 2. So in question 2, John either takes an nCr or a bus to school. And then if he takes nCr, he has a probability of 0.7. On the other hand, that means the remaining 0.3 will be the probability to take a bus. And now if he takes an nPr, then the probabilities of being late will be 0.2. And if he takes a bus, the probability of being late will be 0.4. Therefore, you can see the probability of being late depends on what transports does he take. And so it means that when we combine the events of which transport is taking and also the probability of being late, then this second probability will be depending on the first. And also the combination of the probability will be according to the first one multiplied with the second one. So to handle questions of this kind, usually tree diagram can be very useful. So we can first find the transport and then originally put it into the nCr or to the bus. And then next we check whether it is late or not. Okay, so in a tree diagram like this, then we will also put the probability of each branch next to the branches. So there is a 0.7 of probability for taking nCr, therefore we put 0.7 here. And while for bus, we put the remaining 0.3. And then for taking nCr, then the probability for late or not, then for the probability of late for nCr will be 0.2. while the probability of late for bus will be 0.4. And therefore this will be the remaining 0.8 and 0.6. Now, so the question asked is the probability that he is not late on a certain school day. Therefore, the cases that he is not late will be this one and also this one. And which means this one comes from the branch for nCr not late and bus not late for the other branch. And so the final result, the final answer for this question will then simply be the probability. So I usually write this as the first step, and then it will be the nCr and then not late, or bus and then not late. And then after the calculation, then we will have it is a 0.56 together with a 0.18, therefore it gives us 0.74. So this is question 2. Now for question 3, then it is a case with the number of coins. So in the question, there are two 50-cent coins. For better understanding, I usually change it into words. The words change into symbols. The 50-cent coins, it means a $0.5. And there are two of them. And then there is a $1 coin for 3 of them, and $2 coins for 2 of them. So if 2 coins are taken out one by one at random without replacement, find the probability that the amount is enough to pay a bill for $2.5. And so it is the required amount is at least $2.5. And then now you will discover from the amount of money given, if you want to pay a bill of $2.5, so you must at least take one of the $2 coins. So to find the probability of this question, we try to consider the original method. So we are going to draw 2 coins out, and then the cases would be either the first one is a $2 and then the second one is not, while it can also be the first one is not a $2 coins while the second one is not, or the third case is both are $2 coins. So we find the cases one by one. So the first case will be $2 and then another one not $2, and then the probability will then be the first one $2, therefore 2 over total 7 coins, and the second one not $2 coins, then therefore altogether 5 of them, because it is a 2 plus 3. And then while for the denominator, since it is the second coin we take out, then the total is no longer 7, because we have already taken out 1 coin, therefore it is only 6. While the second case, it would be not $2 coins and then another is a $2 coins, and therefore it will be first beginning with a 5 over 7 for not $2, while the other one will be 2 for the $2 coins, and the denominator is also 6 because we have already taken out 1. Finally, the third case will then be both are $2 coins, and then therefore it would be 2 over 7 for $2 coin first one, and the second one only 1 $2 coin remains, therefore 1, and then also only 6 coins remains, therefore over 6. And then after all these we add them up, then we can have the answer. So let's put them together as a one step. Then the probability will then be 2 over 7 times 5 over 6 plus 5 over 7 times 2 over 6, and then plus 2 over 7 times 1 over 6. And then simplifying everything, so this 2 and 6 we can cancel it first, 2 and 6 we can cancel it first, 2 and 6 we can cancel it first, and then all in all then we will have 5 plus 5 plus 1, so 11 over 21. That's the answer. And as a short remark here, we can see that the first 2 cases is in fact just a permutation of 2 and not 2, or not 2 and 2, so they just interchange the order. And when we find their probability, you can see the numbers are appearing in approximate position, but then just the order is different. So 2 5 becomes 5 2, but then the denominators are the same, and therefore sometimes we will put this together by times 2 when it is a permutation of just some order. Also, this is question 3. Next, we move on to question 4. So in question 4, there are some red balls, so we don't know how many. Maybe we can let it X and find it later. And then 45 white balls in a box. If a ball is drawn at random from the box, then the probability of getting white is 9 over 14. Therefore, this probability can help us to find the X. Now, 2 balls are drawn one by one at random from the box without replacement. Without replacement, that means we draw it and then we do not put it back. And then so find the probability of getting 2 red balls. So I think we need to find the X first using the probability. Therefore, it can be the probability for white ball, therefore 45 over X plus 45 is 9 over 14. And so we can do a multiplication, 45 times 14, so it is, so I haven't got a calculator right here. Okay, maybe I can use a calculator from the computer. 45 times 14, or 630, equal to 9x, and then plus 45 times 9, 9 5 45, 9 for 405, and therefore minus 405, then it's 225, and then divided by 9. Okay, x is 25. And after finding x, then the probability of getting 2 red balls, that means we just draw the red balls one by one. And since both are red ball, then the order first red ball, second red ball, the order is not very important. And so the probability will be 25 red balls out of the 25 plus 45, that means 70. And then times the second red ball. Since the red ball is not put back, therefore it is 24 remains. And also the total balls will be 69, what remains. And then so we find the probability. Okay, I think I better really got a calculator. So the probability will be 25 times over 70 times 24 over 69. Therefore, it is 20 over 161. Okay, so this is question 4. Now the next is question 5. There are 4 white eggs and 8 yellow eggs in a box, and then Terry tries to take out 2 eggs randomly, one by one, from the box without replacement. Again, here is a question for without replacement. That means after drawing, we did not put it back. And find the probability that the 2 eggs are both white. Okay, so for both whites, that means the probability we can do it with simple multiplication, but then remember it is without replacement, therefore the numbers will be changed after the first draw. So the probability for both whites, then it will be 4 over 12, totally 12x, and then the second one will be taken out 1 white already, therefore 3, and then the total will be only 11, and then therefore this probability will be 1 over 11. So for part B, they are of the same color. Then this same color means it is either white or yellow. But for white we have already done in part A. Therefore we just need to do also part B, the yellow, and then add them up. Then that would be for part B. So the probability for part B will then be 1 over 11 for white, and then we do it for yellow, and then which is 8 over 12, and then times 7 over 11. So we don't explain too much about that. After taken away, then subtract by 1. Okay, then we just press the calculator for the rest. 1 over 11 plus 8 over 12 times 7 over 11. And then the answer 17, sorry, suddenly changed to an eraser. 17 over 33. So this is the part B. While for part C, it is about a special kind of question called a given that. That's a conditional probability. However, in DSE, the conditional probability type questions has never appeared. Therefore, I think we better skip it. And so we skip this one because the given that type question has not appeared at all in DSE. Therefore, we skip it, and then later, maybe I think when I return to school, and then we may, and if we have time, then we may talk about that. And I think similar things will go for question 6 as well, for the given that type. Okay, so for question 6 here, there are 4 different pairs of gloves in a bag. 4 different pairs, be careful, 4 different pairs, that means there are altogether 8. Okay, there are 8 gloves in a bag, but they are in 4 pairs. That means maybe 4 different pairs of color, maybe red, yellow, blue, green. Okay, Jessie draw gloves one by one at random without replacement until a matching pair of gloves is obtained. Okay, so she draws it one by one. Again, also it is about without replacements. After drawing, does not put back. Of course, does not put back. Otherwise, then it will be useless. She can never get a pair. Okay, so find the probability that she needs exactly 2 draws. So for exactly 2 draws, then it means that she is really lucky, and she can draw one, and then the second one it match or the same pair. Okay, that means the case. And so it's like filling in the blank thing is that we are going to draw 2 gloves, and then to make a matching pair in exactly 2. That means we the first one can be anything, while after having anything here, then the second one match with the first one. Okay, anything for the first one, and then the second one match with the first one. Therefore, for this probability, then it can be found like this. The first one can be anything. Therefore, it will be 8 over 8, any of the 8. And while the second one must match with the first type, and then therefore, after drawing the first one, only one left will be matching with the first one. Therefore, 1, and for the denominator, 1 fewer. Therefore, it is 7 only. And therefore, the probability for part 1 is 1 over 7. Or sometimes to make sometimes to write this easier, we will just write this as 1 for anything. Any match is okay, then we will just write 1. Now next for part 2. For part 2, then it is exactly 3 draws. Exactly 3 draws means again, if we are to use the fill the blank method, then the first one can be anything, while the second one does not match, and then while the last one can match with either of these. Okay, so it will be the idea like this. So the probability will then be the first one can be anything, while the second one does not match with the first. Therefore, denominator is 7, we write it first. But it does not match with the first. Therefore, we could not choose the one from the first pair. Therefore, only 6. Because there is exactly 1 that match with the first one. But now we don't want to have that match. Therefore, it will be 6. And then finally, the third one, so 6 remains. And then among these 6, it can either match with the first or match with the second. Therefore, it is altogether 2. So this 2, it match with first or match with second. And therefore, the step for finding the probability will be like this, and then the final result will be 2 over 7. Because we can cancel the 8, cancel the 6. So this is for the part A2. While for part B, again, it is a given that type question, and it has never appeared in DS exam. Therefore, I think we skip it here for the moment. And so this is for the worksheet 11.5. So now we go on to the section 11.6 of the worksheet. And then here in the section, we are going to use the permutation and combination to help us find probability. So to recall, the permutation, which is the nPr, helps us to find the number of ways if the order is important. On the other hand, the combination, that is the nCr, helps us to find the number of ways when the order is not important. We don't count the order. And now, so in the last section in 11.5, we learned how to find probability by multiplying them step by step. So step 1, multiply, find the probability, and then multiply to step 2, find the probability. And then if there are more steps, we can go on the multiplication. Now, on the other hand, sometimes we can directly find the total number of ways for denominator, the total, while for the number of ways that we require in the numerator. And then if we can have some ways like nPr, nCr to find the required one easily, then we can also do it with nCr or nPr. So let's see some examples to help us understand how we do it. So let's see the question 1. There are altogether a collection of 12 stems, and what are they? And they are 5 square stems, okay, the square stems. And then there are 4 triangular stems, and also there are 3 circular stems. And so if we select 3 at random, 3 stems are selected at random, find the probability that the selection includes each shape. And so if we want to use nCr or nPr, that means then the numerator will be 1 for each, and that means so it will be a fraction, and then the numerator will be 1 for each. That means we choose 1 from square, choose 1 from triangle, and choose 1 from circle. And so the total number of ways will be 5 times 4 times 3, choose 1 from each. While the denominator will be the 12 of the stems, and then we choose any 3 of them, therefore 12C3. and then that will be the answer 5 times 4 times 3 over 12C3. So which is change it back to fraction, then it's 3 over 11. Okay, so this is how we do part A. Of course, we can use the old way of finding probabilities by multiplying one by one, but then you will see there is a little difference. So or we can also do it like this. The probability will be it's like a filling in the blank way that we usually do. Filling in the blank, choose 3, and then it can be square, triangle, circle, or it can also be other things like a square, circle, triangle, or etc. And then altogether these shapes can permute one by one. That means altogether a 3 factorial of them, and therefore we can also find it by 5 over 12, and then the second one 4 over 11, one fewer, and then the other will be 3 over 10. And then but altogether there can be a 3 factorial of them, therefore we multiply it by 3 factorial, and then I think we will also get the same answer. And then in probability, it is that if we can have different ways of counting but we get the same answer, then we are sure that our answer is correct. Okay, so this is another way to do the part A. Now back to part B. So now part B will be, it does not include any square stems. That means in the requirement, that is the numerator. So if we are to put it into the numerator denominator form, then the numerator, we don't want to have any square here. And then no any square here, that means we can only choose from the remaining, therefore 7C3. While the other one will be, the denominator will be the same, 12C3. And then we press the calculator and get the answer. 7C3 divided by 12C3. And so it is 7 over 44. Or we can also do it with the multiplying probability method. So we can also do it by the first one, choose from the 7 not square over the 12. And then the other one, the next 6 remains 11. And then the other one, 5 remains over 10. And I think you will also still get the same answer. 7 over 12 times 6 over 11 times 5 over 10. So also 7 over 44. Both can do. Okay, so this is question 1. Before we go to the next question, we have a short remark here for the part A. This short remark is that in fact this is a usual and important type of question that we usually see in DSE. It is the type of question for selection from different groups. Here altogether we have 12 stems, but these 12 stems are in different groups. The square stem or triangle stem or circle stem. And then they are in different groups. And then here we try to choose from different groups. So if we are doing multiplication from different groups, then this multiplication does not count any order. Okay, I put it again. So if we are doing a multiplication to choose from different groups, then this multiplication, the result does not have any order. Therefore, when we find the probability, then we see this is 5 times 4 times 3. I said that it has no order, while the denominator 12C3 also has no order. So the remark here for you will be this 5 times 4 times 3 does not have any order. I put it no order here. And also here we use C, therefore it also has no order. Then we can find a probability for this one. If we can match the numerator no order and the denominator also no order, then the probability is okay. While for part B, we have something similar. Also, we can see this is C and C, therefore both are no order. And so it is okay. While for the alternative one, the blue steps for finding probability. Okay, so this is the probability multiply probability multiply probability. We can interpret it as as 7 times 6 times 5 over 12 times 11 times 10. Or if we put it into the symbol for nPr, then this is indeed 7p3 over 12p3. And then you can see that the denominator and the numerator here both has order. And then the flexibility for probability is that if we are finding probability, you just need to match, you just need to be sure the numerator has order, denominator has order is okay. The numerator has no order, the denominator has no order is also okay. So the flexibility is that we just need to be sure both are the same kind of counting. So if it is the counting for order, then you can find the probability by 1 over the other. If both are the same kind of counting with no order, then you over them 1 by 1 over the other, then we can also find the probability. And you will see they are the same result. So the key is they are the same kind of counting. The same kind of counting. Okay, then this is question 1. So it is especially important because it is a very frequent kind of question we see in DSE. So next we go on to question 2. Now there are 6 English books and 5 Chinese books on the bookshelf, so total 11. And Candy select 4 books from the shelf at random. Find the probability that all books selected are of the same language, so choose 4. Therefore, I think this can be a good exercise for whether you understand the selection from groups. Again, it is a selection from the English group and also the Chinese group. So the probability will then be, so Candy selects 4, therefore everything select 4 for the denominator. While same language, that means it can be all English or all Chinese, therefore 6C4 plus 5C4. And then this first one is for all English, while this second one is for all Chinese. And then we add them together because it can be either all English or all Chinese, so add for all. And then we press the calculator for the result. So 6C4 plus 5C4, and then over 11C4. And then we have the answer is 2 over 33. I think it can be a good exercise for selection from different groups. And then so next, at least 3 Chinese books are selected. So when it is at least 3 Chinese books, we just check how many cases are there. Then it can be 3 Chinese, 1 English, because altogether she wants to get 4. Or it can be 4 Chinese, so only 2 cases. Therefore, we check the 2 cases 1 by 1. So the probability will be everything select 4, and then the first one will be for 3C, 1E, 3 Chinese, 1 English. Then this is the idea for selection from groups: 3 Chinese, so 5C3. And then 1 English, 6C1. Or, so it add to the other, or it can be all Chinese, so 5C4. And then put them together into the step, and then press calculator and get the answer, 5C3 times 6 for 6C1, and then add to 5 for 5C4, and then over 11C4. And then we have the answer is 13 over 66. So this is question 2. Question 3. 10 volumes of a series of books are arranged at random on the bookshelf. So there are altogether 10 books. And the final probability, the first volume is on the left end, and the 10th volume is on the right end. So consider the fill the blanks method. Then we want the first one to be left, and then the 10th one on the right. And that means these two are the fixed position. And then while the requirement will be these two are fixed, while the other can be free. And then so the probability will be simply to put the numerator with the requirement and denominator with no requirement. For no requirement, it is not hard because it is just the 10 books randomly permute. Therefore, it will be 10 factorial for the denominator. But for the numerator, 1 should be fixed and 10 should be fixed here. Therefore, all 3 choices are the middle 8. Therefore, it will be 8 factorial. So pressing calculator, it will be 8 factorial divided by 10 factorial. And we have the answer is 1/90. So for part B, then the second and third volumes are next to each other. And when we see next to each other, then we try to trigger our way of counting for the binding method. So we try to bind 2 and 3 together as 1. That is, we try to put the 2 and 3 together, bind it as only 1. Okay, then if we try to put them as only 1, then there are only 9 things left. And so for the probability, again the denominator will be 10 factorial because it is no restriction. While for the numerator, there are only 9 things because 2 and 3 are put together as 1, therefore it will be 9 factorial. And also the 2, 3 itself, it can change 2, 3 or 3, 2. It can permute itself. Therefore, we multiply it with a 2 factorial. And then after all calculator, then we find the result. 9 factorial times 2 factorial and then divided by 10 factorial. Then it will be 0.2. That means it is 1/5. So this is question 3. And to remind you that the part B is about the binding method. It's also one of the common question type we see in DSE. Next, we have question 4. Okay, question 4. A 4-digit number is formed by using the digit 2, 4, 6, 7, 8, 9. So there are 6 here altogether. If repeated use of digits is not allowed, so you use it, then you cannot use it again. And find the probability that the number formed is even. So again, we can use the filling in the blank method. We want to find out, put a 4-digit number, and then of course the original. If there are no special requirement, then just 6 choose 4, and they are the number. Therefore, the odd order is important. Therefore, it will be 6p4. So we can put the denominator first. So the probability will be 6p4 for the denominator because we cannot use it again, and also the order is important. Okay, well now while if it is for even, then we want the last one to be even number. That means it's 2, 4, 6, 8. And so out of here 4 of them we can choose. While the remaining are 3 choices because the only restriction is on the last number. Therefore, the remaining we can have 5, 4, 3. Okay, just fill the blanks one by one. Therefore, it will be 3 times 4 times 5 times 4, and then that will be the result. So let's see it. The result: 3 times 4 times 5 times 4 over 6p4, and then this is 2/3. Next, it is question 5. In a box, there are 4 red balls, 5 green balls, and 6 blue balls. Oh, RGB, okay. 3 balls are chosen from the box at random without replacement. Again, we do not put it back. And then find the probabilities that all the balls are the same color. Okay, so all same color, and we choose 3 here. Choose 3. Choose 3. And so for part A, again, they are the selection from different groups. So for the probability, then altogether there are 4, 5, 6, that means 15. 15 balls choose 3. The denominator will be 15C3. And then for the numerator, then it all are same color. Therefore, it can be either all red, or all green, or all blue. And therefore, so it can be 4C3, or then we add them up, 5C3, or 6C3. So we add up all the different cases, a longer denominator line, the fraction line, and then we just press the calculator. So 4C3 is 4, 5C3, and then add to a 6C3, and then over a 15C3. And so we have the answer. Okay, so it's larger, 34/455. So for part B, they are of different color. So all are different. That means no two same. Therefore, we will choose one from each group. And then so the probability is not hard to find. In fact, quite easy to find. Is that we just choose one from each group. Therefore, it's 4 times 5 times 6. And then over the denominator will be total 15C3. Again, here remind you, when we choose one from each group, then the multiplication does not have order, because these groups are independent with each other. 4, 5, 6, then they have no order. Okay, and then the result will be 4 times 5 times 6 and then divided by 15C3. Therefore, we have the answer is 24/91. Okay, part C. And then there are exactly two colors of balls. Okay, exactly two colors. That means either it is red green, or it is red blue, or it is green blue. But then if we can achieve, like for example, if we have red green, that means 3 balls are chosen. Therefore, it can be 2 red, 1 green, or 1 red, 2 green, or the similar things for other cases. But then you can see there are in fact many cases to consider, because even just red green, we can be 1 red 2 green, or 2 red 1 green, and there are also red blue, and also for green blue. There are too many cases. But then if we think carefully, then you can see this part C is just exactly the opposite of the other two. That means they are not all same color, not all different. Then this would be the part C. Therefore, the easy way to find the probability for part C will be just take the opposite of one of A and B. That is, we do a 1 minus A and then minus B. And then that is 1 minus 34/455 and then minus 24/91. And then we just press the calculator. And this is 43/65. So sometimes this is also about the reverse problem. Sometimes if we find the reverse problem, the 1 minus case, the opposite case is easier to count, then do the opposite. So for question 6, it is an optional question. So I think I will leave it to you as your challenge, and we can check the answer when I come back to school. So for question 7, there are 4 secondary 6 classes, so 4 classes. 2 students are selected from each class to form a committee for graduation dinner. And then from the committee, so in the committee, there are 4 classes, 2 of them from each class. That means altogether 8 people in the committee. Okay, from the 8 people in the committee, 2 students are chosen at random as a contact persons. So from these 8 people, choose 2. And then find the probability that the 2 contact persons are from different classes. And in fact, this one is quite like DSE 2012, the first year DSE, very like. And we have also done it before, if you remember. We have do it in our extra set of permutation and combination notes. And then that is for there are 4 departments in a company, that question. Okay, anyway, so find the probability that the 2 contact persons are from different classes. And then to find the probability, we put it again in the denominator and numerator type. Okay, so but I think it would be easier if we find the 2 contact persons are from the same class, because the 8 committee members come from the 4 classes. Therefore, if we can find the 1 minus the probability for same class, then it can be easier to find maybe. So we try it. For same class, then of course the choice will still be 8C2, because 8 from everything, and then choose 2. But if they are from the same class, then it can be either from the 4 classes, either class A, class B, class C, or class D. So the only possible numbers for number of ways for same class will be either A or B or C or D. Therefore, only 4 choices. And then so this will be the result. So 1 minus 4 over 8 C2, and that is 6 over 7. Of course, if you want to choose really the different classes, then we can or we can do it. Okay, so let's try more different ways. Or the probability, if we want to find directly, we don't want to use the inverse method, then again it will be 8C2 for the denominator. But for the numerator, we first choose which two classes to find. So there are 4 classes here, we choose 2 classes first. And then after choosing the class, we also need to choose the representative, because each class has got 2 students. Therefore, it will be 2, I think it's better to write 2C1 and then also 2C1. So after we choose the 2 classes, then these are the 2 classes representative. And so we can also press the calculator for this one, see if it is the same as the first answer. So 4C2 times 2 times 2, and then divided by 8C2. Alright, so you see, oh, it is also 6 over 7. Again, it is the same saying that when you have 2 different ways to find the probability to count the numbers, and then you find the 2 different ways give you the same answer, then that means your answer is quite correct. Okay, so this is question 7. And then now, next, let's go to question 18. Question 8. And then there are 12 black chocolates and 14 white chocolates in the shop, so altogether 26. And then Alan picks 6 chocolates, picks 6 at random to form a chocolate box, and find the probability that the box has black chocolates only. So that means it's again selection from black and white chocolates, 2 different groups, and then the probability for part A will be only one of the group. And then so the probability, I think it should be not difficult to find. It will be then, it is only black, therefore 12C6, choose 6, and then from everything 26C6, and then we have the result. So just press calculator. Oh, the number is very small. Okay, it is 6 over 1495. It's better to give fraction usually. So part B, then it has at least 2 black chocolates and white chocolates. So it's choose 6. And then now our requirement is at least 2 black and at least 2 white. And therefore it will be better if we list the cases one by one. At least 2 black and at least 2 whites, then it would be 2 black, 4 white is okay. Or it can be 3 black, 3 white is also okay. Finally, it can be 4 black, 2 white is also okay. But then if there are more black, then the white will not satisfy the requirement. Or if there are more whites, then the black will not satisfy the requirement. Therefore, there are only 3 cases. And so we find the cases one by one, and then we can have the answer. So again, the denominator will be 26C6, while we put the cases one by one, case 1, 2, 3. Or maybe, okay, I put it different color. Case 1, and then 2, and then 3. Okay, so the first one, 2 black, 4 white. So 2 black, and then 4 white. And the second one, 3 black. Why is it not blue? It's blue. Okay, it is 3 black, and then 3 white. And finally, it is 4 black, and then 2 white. And so put them all together, and then add them up, and then press calculator. So 12C2 times 14C4, and then 12C3 times 14C3, and then 12C4 times 14C2, and then over the denominator 26C6. And so this is 191 over 230. So I hope I do not press the calculator wrong. But if I really press the calculator wrong, this is in the video, I cannot change it. So you change it for me. By the way, here I remind you that it is at least 2 black, 2 whites, but we talked about that before. We cannot choose 2 black and choose 2 whites and then choose remaining anything. It is not a correct way to count because there can be many double counting involved. So for details, I do not repeat it again. We have talked about it earlier. Now there are 2 questions left. We also talk about it. Question 9. So it is a DSE 2016 question. So 4 boys and 5 girls randomly form a queue, and then find the probability that no boys are next to each other. So I here highlight the keywords again. No boys are next to each other. That is try to trigger you to remember the question type. It is the separation method. We have to separate the boys, and to separate the boys we use the girls to separate the boys, and 5 girls all together. There will be 6 spaces counting from the beginning to the end. Therefore from the 6 places, so to find the probability, of course the denominator for the probability will be all of them lined up randomly, therefore 9 of them and then factorial. But for the for putting the boys, separate the boys, then there are 6 spaces between the girls, and then from the 6 spaces we choose 4 of them for the boys. And then after handling the boys, then the girls themselves can also permute, therefore the girls 5 factorial, and that will be the answer. So it is 6p4 and then times 5 factorial over 9 factorial, and then the answer will be 5 over 42. So this is a DSC question, and DSC also asks for separation question. I think it's about 1 or 2 years. Finally, this is a question from our S6 mocks some years earlier. And then there are 7 pairs of socks in a drawer. Oh, by the way, here 7 pairs, it means 14 because 7 pairs. And the color of each pair is different. That means there are 7 colors. Okay, for example, you can consider it as the colors of the rainbow. And then from these 14, we draw 8 socks at random from the drawer. And then when we draw the socks together, it means we draw it, we do not put it back. Find the probability that the 8 socks drawn form exactly 4 pairs. Okay, so to find the probability for 8 become exactly 4 pairs. Of course, the probability for the denominator will then be 14C8. But then for the numerator, the requirement will be exactly 4 pairs. Therefore, we just need to choose what 4 pairs are chosen. And so altogether there are 7 pairs, then among the 7 we just choose 4 pairs. And this will be exactly the result. We do not need to do a second step to choose which socks because both are chosen. Because the 8 socks here, we want to choose exactly the 4 pair. That means we choose which pair to choose, then both socks in the pair are all chosen. And so the 7C4 will be the result. So 7C4 over 14C8. And then we have the result. Oh, it is a very rare. It is 5 over 429. Next, part B. So find the probability that the 8 socks drawn form at most 3 pairs. Here at most 3 pair means less than or equal to 3. And since for 8 socks at most you can do is 4 pair. That means now it is at most 3. That means we just not want 4 pairs. And so the probability for part B is very easy, because it is just the 1 minus the part A. It's just the exact opposite. So exactly 4. And then if we don't want exactly 4, then it is at most 3. And therefore it is just 1 minus 5 over 429. That is 424 over 429. Okay, so this is question 10. And then here we have finished this worksheet. And I did not do the question 6, and I keep it for you as your challenge. So I hope I can recover from the COVID, and then I can go back to school and discuss more with you. So that's all for this worksheet, and then I hope to see you when I return to school. Okay, goodbye.